Hmm.
Sekarang saya tentang doa lah.
Doa, okay.
Um, Doa ni patut jadi amalan harian kita, sebabnya doa ni menjadi macam macam kita letak pengharapan kita dekat Allah. Contoh sebelum kelas ke, kita doa dulu supaya kita dipermudahkan. Contoh kita baca Allah maftah alaina sebab itu. Lepas tu macam sebelum makan kita doa Allah berkati apa yang Allah bagi kat kita. Lepas tu sebelum naik kenderaan, makna hidup kita ni kalau dipenuhi dengan doa, makna kita macam letak tawakal kita lah kat Allah. Makna kita perlukan Allah dalam kehidupan kita. Itulah.
Okay, very good. Very good. So yang lain get ready ya. So boleh siap skrip awal-awal untuk menunggu hadapan. So very good tazkirah on doa. Doa is also an ibadah, which means that every time kita doa tu kita dapat pahala pun. Padahal kita minta pertolongan Allah, kira macam kita ini. Tapi Allah tu Maha Pengasih, bila kita berdoa itu pun dapat pahala. Dan Allah suka. Lagi banyak kita berdoa, lagi banyak Allah suka, Allah sayang kita. Sebab Allah akan sayang kita bila kita merasakan diri kita hamba. Bukan bila kita rasa kita hebat, bila kita rasa diri kita hebat, kita di sisi Allah tu darjat kita tak tinggi. The highest darjat di sisi Allah bila kita menjadi hamba. Bila kita depan Allah tu kita jadi hamba. Hamba ni memang lemah, tak hebat, serba kekurangan, memerlukan. Bila kita ada unsur-unsur kehambaan ni depan Allah, amazingly darjat kita akan naik dan Allah akan sayang pada kita. Bila Allah sayang pada kita, banyak benda yang Allah akan mudahkan untuk diri kita. So dia macam opposite dengan manusia kan. Manusia kalau humble yourself depan manusia, orang akan pandang awak lekeh. Dia ni macam awak kata saya tak pandai menulis, tak pandai, mesti kata ya apa ni. I mean manusia akan pandang awak macam tak ada harga. Tapi it's opposite, sebab tu kehambaan tu hanya dengan Allah, dengan Tuhan. Dia tak boleh menghambakan diri pada manusia, hambakan diri dengan benda-benda lain. So bila kita menghambakan diri dengan Allah, Allah akan naik darjat kita di sisi Allah. And one of the best time to make doa bila?
Waktu sujud.
Okay.
Waktu malam.
Malam mana?
2/3 malam.
2/3 malam. Lagi?
Hari Jumaat.
Hari Jumaat. Hari Jumaat kan ada specific timing yang hari Jumaat?
Antara kutubah.
Yang in between khutbah satu lagi lepas asar. Sampailah maghrib. Tu memang powerful time kalau awak nak make doa. I'm sure all of us need doa, right? I mean, awak belajar sekuat mana pun, you still need Allah's help. Awak belajar macam mana, awak hebat macam mana pun, still kita perlukan Allah's help. So kita carilah time-time yang powerful ni untuk doa. And especially through Qiyamul Lail, tahajud. Nak tanya, siapa bangun tahajud semalam? Okey, siapa bangun tahajud minggu ini?
Terbangun, madam. Terbangun.
Terbangun? Okey, alhamdulillah terbangun. Seorang je minggu ini?
Kena bangun hari-hari.
Kena bangun hari-hari, kenapa?
Dekat rumah.
Duduk rumah, ayah awak kejutkan?
Uh-uh.
Alhamdulillah, syukurlah awak ada mak ayah yang nak kejutkan bangun qiyam. So, tu pun kena bersyukur. Kalau duduk kat UIA, tiap-tiap hari ke? So, so siapa hak lain tak jawab dalam minggu ni ataupun semalam tu, Saya tak tanyalah bulan ni, takut bulan ni pun tak ada juga dan tahun ni ada ke tak. So bila saya pernah tanya student, dia kata, oh tahun lepas madam, Ramadan. So, Ramadan setahun sekali ya, dia tahajud. So tahajud ni bukan untuk Allah, bukan maknanya the benefit tu not for Allah, benefit to us. And one of the powerful time to make doa. And tapi dia punya key dengan doa ni, dia kena ikhlas and minta bersungguh-sungguh. Kalau minta macam Rabbana fil lana dzunubana wal walidina warhamhum, gitu doa yang macam half-heartedly, yang macam tak ada jiwa kat situ. So it's very difficult for Allah nak Allah takkan easily nak mabulkan. Doa yang powerful ialah ikhlas yang penuh dengan jiwa. And pada timing-timing yang tu, kalau awak bangun tahajud pun, awak doa tak bersungguh pun mungkin tak powerful. So if you really want something in your life, wake up for tahajud. And then ask Allah, sebab ada hadis Nabi kata masa 2/3 ke 1/3 malam terakhir tu Allah akan turun ke Allah akan turun ke, pernah dengar tak hadis tu? Oh, Allah akan turun ke langit dunia time tu. So makna nak tunjuknya berapa dekatnya, sebab tahajud ni powerful sebab orang lain tidur bangun. And Allah suka benda-benda yang macam hamba tu menonjolkan diri di depan Allah. Sebab orang lain tengah tidur. Tiba-tiba kenapa hamba ni bangun untuk bermunajat dan mohon ampun ke minta pertolongan Allah. So dia jadi special because orang lain tak buat. Sangat jarang orang buat tahajud ni. So kalau kita depan orang raja ke king, kita nak tunjuk kita special kan. Macam itulah dengan Allah tu, kita nak tunjuk kita special dengan bangun tahajud. So dia memang, kalau macam for example semua geng-geng awak, katalah geng-geng awak tengah I don't know buat benda lara, main game, for example main game, bersungguh main game, tapi masa tu awak tak main game, awak ingat Allah, sembahyang 2 rakaat sunat, masa tu you will stand out in the eyes of Allah. Dia memang gitu, dia memang orang tengah lara ke tengah buat dosa ke, masa tu you ingat Allah, pahala dia tak sama bila semua orang semua orang baik, semua orang buat benda baik. So dia punya konsep dalam Islam tu macam tu. Sebab tu tahajud tu special, sebab ramai orang tidur masa tu. Tapi ada beberapa orang yang Allah telah pilih untuk bangun untuk tahajud. And bangun tahajud ni Allah pilih. It's a gift. So kalau kita minta lah dengan Allah bagi kita bangun tahajud. Kalau kita tak boleh bangun tahajud tu, something not right dengan hati kita. Banyakkanlah solat taubat, minta ampun dengan Allah so that kita boleh bangun tahajud. Sebab not everybody Allah gives opportunity nak bangun tahajud. Okay. Saya nak share, saya bangun tahajud semalam. Lepas tu I had a really big problem yesterday. Sampai saya tak boleh tidur. Pukul 3 tu saya terjaga tak boleh tidur. I tried to sleep. Saya nak bangun dekat-dekat dengan subuh. So that tahajud pun lambat-lambat lah. Tapi macam I can really sleep at 3. So okay, I think let's go back to semiconductor. Nak dapat A semiconductor pun boleh tahajud juga. Kok lah minta Allah lembutkan hati lecturer ni. Make it easier, you never know. My heart also Allah yang pegang. Okay, saya share screen. Share screen. Nampak? Can you see?
Yes.
Alright, so last time we stopped at conductivity, mobility, diffusion. Saya ada suruh buat apa-apa ke? Tak ada. Tak ada, saya tak suruh cari apa-apa.
Baca je.
Apa, Aiman?
Ada suruh baca.
Baca apa?
Drift and diffusion.
Okay, great. Okay, who wants to tell me? Let's stop sharing. What do you understand from drift and diffusion? Thank you, Aiman, for reminding. Siapa tak baca, bersedia kena tembak. So, who wants to start first? Baru nak Google ke? Siapa dah baca? Beritahu lah apa-apa what do you understand about drift and diffusion.
Let me start first.
Okay, Azam.
From what I'm reading, drift, there are two types, N-type and P-type. For N-type, N-type have less number of free electron. When electric field applied to this large number of free electron, then the electron will go opposite with the electric field. Is it?
Okay, teruskan dulu. Saya macam saja nak dengar lagi. Okay.
And then the p-type, which less number of hole. When
Kenapa awak kata less number of hole?
large number of hole.
Oh, large. Tu saya duduk confused. Saya dengar less. Kenapa? And
Less
less
number of hole. When the electric field applied, it will go the same direction with the electric field as a positively charged.
Okay, good. How about diffusion?
Diffusion, diffusion saya confused. Saya baca tapi confused.
Okay, siapa nak tolong on diffusion? Solihin?
Yes, madam.
Tell us about diffusion.
I haven't read it, madam.
What's the music?
Okay. Alright, tak baca lagi. So saya akan tembak satu. Aiman.
Diffusion is the flow of particle from high concentration region to the low concentration region. For the electron, the flow of the electron diffusion is the opposite of the electron diffusion current density, while the hole diffusion has the same direction as the current diffusion.
Okay, thank you. Good, Aiman. Can you summarize Hanbali, the two drift and diffusion? Tak dengar. Oh, kenapa tak berdengar? Awak punya tu tak plug in betul-betul ke? Ikutlah dia terlonggar ke apa ke? Masih tak dengar. Orang lain dengar ke?
Tak dengar.
Tak.
Jadi okey je.
Tadi dia bersuara ke?
Tadi saya meeting dengan dia.
Apa cerita tiba kelas saya ni? Sabotage ke? Hambali. Okay, sementara Hambali fix the technical problem. Let's hear from Najwa.
Saya tak dengar sangat tadi Aiman cakap pasal diffusion.
Awak tak dengar sangat Aiman cakap pasal diffusion. Okay, Aiman sila repeat.
Diffusion is the flow of particle from the high concentration region to the low concentration region. For the electron diffusion, the flow is the opposing to the current diffusion, while the hole diffusion it has the same direction as the current diffusion.
Boleh, Najwa? So apa beza, so if you understand, Najwa answer this question. What's the difference between drift and diffusion current or process?
Dia involve dengan electric field.
Kuat sikit eh?
Kalau drift, dia involve dengan electric field. Kalau diffusion, dia pasal flow of particle, pergerakan partikel tu.
Awak dengar ke, Faiz?
Just a bit. Dia dengar dia kata pasal kalau drift is
Diffusion.
about involve electric field, and then
Diffusion?
the diffusion something about particle movement, is it? The movement of particle?
Betul Najwa?
Ya. Tadi dengar tak? Slow
Apa benda?
Pretty slow.
Apa benda tak dengar? Saya ni
Dia
masalah, awak semua dengar ke? Saya ke yang tak dengar?
Dia kata slow ke dia punya mikrofon? Yes.
Yes, betul. Saya tak dengar, tu slow lah. You need to shout, Najwa. So,
Ada mikrofon baru.
bolehlah mikrofon baru. Kalau tak ada duit, beritahu saya.
Oh, ya ke Madam?
We'll have a chat on that. Okay.
Adam, I cannot hear you. Can you?
I can hear you very clearly. Okay. Right. So, okay. So basically you understand already lah. So saya tak payah explain lah drift and diffusion. Any question on drift and diffusion? Current and drift. So dia ada drift dengan diffusion. Dia is a mechanism. It's a process. So from this process, we will get the current. Because when we have this process and we have net flow of carriers due to this process, then we have current. So that's why we have the two types of current, what we call it, the drift current and diffusion current. Okay, ada soalan on this?
Madam.
Yes?
Dengar.
Dengar?
So there's a difference between diffusion and recombination and generation.
What's the
Generation.
diffusion?
The diffusion and generation and recombination.
Okay.
The,
Siapa nak
The
tunjuk?
different.
Lah. So macam lebih kurang sama lah. Diffusion, generation and recombination. Apa beza dia? Siapa nak jawab? Banyak beza dia sebenarnya. Okay, siapa nak jawab? Hello?
for you.
Faiz nak jawab?
Tengah fikir.
Okay, I think I can come up with one thing that I can think of. So the difference you said, right? Okay. So when in semiconductor material, you will have the valence band gap and the the top one? Conduction band gap, sorry about that. Okay, so generation is basically generating free electron when an electron from valence gap absorbs energy or
Valence band.
valence band absorbs or get excited from outer energy such as temperature, and then it will move to the conduction band. That's generation. But from the electron in the conduction band, it will create it can create current. So that's where the diffusion comes in. Is that higher density of current from the free electron will create diffusion because it moves from the higher concentration of higher concentration of free electron to lower concentration one. That's what I understand.
Faham Hambali?
Flow of electron in the negative x direction.
Kalau faham
So question, madam, is the diffusion can create current?
Who wants to answer that? Sebab saya baru sebut tadi. Who wants to answer that?
Yes.
Yes.
Yes. Hambali, do you understand Faiz punya answer? Kalau tak faham,
For my understanding, diffusion create current. Recombination and generator create carrier. Is that right?
Tahu dia bergema pula. Jadi dia tak keluar suara ni. Macam mana yang mana? Ada siapa faham tak Abang ni kata apa?
Dia kata drift. Yang drift ni dia create current. Lepas tu generation and combination create electron and hole. Something like that.
Yes.
Okay. Is that what you say? What you say? Hambali? Yes. So everybody agree with that? So dia simplify macam tu. Everybody agree with that?
I guess it's true.
So recombination also create a carrier?
Well, bound carrier. It creates bound carrier in a sense.
Create bound carrier. Okay lah, tapi kita tak kata create, begitu kita kata we are losing free carrier. Okay. So alright. So I think that is a very interesting, very good question. So because kalau tidak akan confuse kat mana. Let me draw to make it easier to understand. Okay, so you have diffusion, and then you have generation, then you have recombination. To understand this best is actually by looking at the energy band diagram. Okay. So this is a summary. So generation is generation of free carriers from, so for example, electron from the valence band to the conduction band. That's generation. Recombination is recombination of free carriers from conduction band to valence band. Here you create free carrier. Here you lose free carrier. Okay, so here you absorb energy. Here you release energy. Right? Sebab you lose energy, you lose free. So what is diffusion? Okay. Diffusion and drift. Diffusion you okay, kalau diffusion saya draw kat bawah ni pula. Alamak, tak ada bola kat bawah, kena time pula. So kalau diffusion, okay, normally kalau diffusion kita draw in terms of ni. Saya tunjuk dia dalam energy band diagram because it's just a current who looks the same, drift and diffusion. Tapi kat sini saya draw in terms of material tu, drift, diffusion. So this is a semiconductor material. Okay. So then you have free carriers. Drift, macam sebut tadi, dia punya syarat lah. The biggest difference with drift and diffusion is drift will require electric field. So you need to apply voltage. Okay. So when you apply voltage, what happens is you have electron. So the sentence will be electron will drift to the positive side. Hole will drift to the negative side in this influence of the electric field. Okay. For diffusion, you don't have electric field. You don't need to apply electric field, but the carrier will move due to difference in concentration. For example, yang senang nak to imagine this is like if you remember in your SPM, you still remember in your SPM there's a I don't know, experiment yang gas tu. You put two gas together in one, you have gas A, gas B. So if you put in one chamber the two gas, what will happen?
The higher density gas will go down, while
Yeah,
the lower density will go up.
so it will go and mix. So in the end, what happens? You have equilibrium, right?
Yes, equilibrium.
Yes. So similarly, for the electron hole, for example, here you have, a lot of electrons. So you put a material with higher electron. Here you have few electrons. So what happens is, this electron will want to diffuse to here. So it will diffuse from a higher concentration to lower concentration, and vice versa. If you have if you have hole, so you have many holes here, yeah, and you have less hole here, the hole will also drift from higher concentration to lower concentration. So that's the principle of drift and diffusion. So remember, when you have net flow of any free carrier, you'll get current, right? So that's why you can have current due to this and drift, and you can have current due to diffusion, even though you didn't apply any voltage to the semiconductor, but there's a difference in number of free carriers, you will still get current. Okay, so bukannya current only through when you apply electric field. Okay, now in terms of energy band diagram, where are they? In terms of energy band diagram, both will look the same. You will see. So here, when you talk about generation and recombination, it's always across the energy band gap. So whenever you do dalam exam, make sure you kena draw semua dia punya gap. You need to label everything. Especially kalau markah dia banyak. If there are a lot of marks, make sure you label everything that you know. Because I will be very detailed on that. So if the marker is very little, okay lah, you can just ignore. Alright, so for the diffusion and the drift, for example here, if you apply a positive here and negative here, the drift will just means that this electron is drifting to this side. Okay, and then the whole drifting to this side. They tak go across. It doesn't go across the band gap. Okay, so in energy band diagram, the flow it depends on whether we put this we put this voltage or no. So for example, if you don't put voltage, so if we see any net flow like this, then we know that this is a higher concentration compared to this. So you have diffusion. And this if the electron hole from moving from here to here, you know this space is with a higher concentration of hole. Macam tu. Okay? Any question? Any further question? Simple, you understand?
So if the carrier want to drift or diffuse, then the semiconductor material need to be must be under generation first, right?
Yes, correct. Yeah, okay. In order for diffuse or drift, there are two ways. Number one is through generation here, process here, but also if the semiconductor material are connected to this electric field and to a complete circuit, okay, what happens is you can have the supply of the electron from the circuit. So maknanya macam gini lah, kita ada semiconductor, kita diode kat sini kan. Diode ni semiconductor diode sebab dia connected dengan macam ni. So the electron number one can come through this. For it to, sebab in the end lah, dia ada complete circuit ni, maknanya ada current will flow. Current will flow. Right? So this current it can be from this generation, and it also can be supplied by the battery. So electrons, but electrons always the opposite direction. Kita kata hole lah senang. So hole pergi kat sini, masuk and follow, go through. Tapi hole tu bila supplied from the battery. Okay. Sebab tapi dalam course ni kita concentrate kat sini je. Kita tak cerita pasal apa jadi kat luar. Okay, any more question? Okay. Okay ke ni?
So far.
Ha? Jawablah okay ke tak okay. Penat dah tanya.
Not yet so far.
Ah, not okay?
Not yet so far. Okay, setakat ni okay lagi lah.
Okay. Orang lain senyap tak, awak tak okay ke apa?
Madam, say okay.
Okay. Alright. Okay, next, let's look at this. So we can have equation for the drift and diffusion. So remember this, we talked about this before, is the drift velocity, and then it's a function of the mobility and electric field. Alright, we talked about this before. Saya tahu kenapa dia lari ni habis di sini. So what they call this the current density is just this what they call it, the drift velocity times the number of free carriers and electron. So we discussed about this. So in a semiconductor, you can have two types of drift current due to electron and drift current due to hole. Okay, so both will drift, but the direction of where it drifts depend on the carrier. So electron, they can always want to go to the positive, hole will always want to go to the negative, and as mentioned conventionally current, the direction of current is the opposite direction of electron. Tu kita tahu from our first year, right? So current, the direction of the current is the opposite direction of the electron and the same direction of hole. Okay. Sebab awak kena tahu ni nanti you need to remember that, jangan tertukar sebab nanti lepas ni ada kita nak cantum dua semiconductor material. Okay, so if it's a hole, the equation are the same except for the mobility is the mobility of hole. So mobility of electron and the mobility of hole are different. Why? Because hole and electron have different mass. Hole is heavier. Hole ni lagi berat. So dia payah sikit nak berjalan. Macam orang gemuk lah. Dia macam jalan pun slow banding orang kurus. So jadi so mobility for electron hole are different. So and then okay, so the free carrier here is the hole instead of electron here. Itu je lah. And the direction pun different. Okay, so that's drift. So the total current or the total drift current is a function of the drift current due to electron and the sum of the drift current due to electron and the sum of the drift current due to hole. So that is the total drift current. So kita kena take both into consideration. Okay. Now, sebab kita ada dua carrier moving in the semiconductor. Let's look at diffusion. As you mentioned, diffusion is flow of particle from a region of high concentration to low concentration, right? And this is the equation for the current density. So the current density is a function of the electronic charge, or electronic charge. Dn here is the electron diffusion coefficient, and this electron diffusion coefficient is different from different material. So each material have its own electron diffusion coefficient. Okay. So maybe, I don't know, in my question, I will ask you select the best material to get the rate. So maybe you need to, if it's an open book, maybe you want to check. You can Google, they will give out electron diffusion coefficient for gallium arsenide, silicon, right? So, and then it's also this current, diffusion current is also function of dN over dx. What is dN over dx? Is the gradient of the electron concentration, meaning how big the difference, okay? How big the difference in the carrier concentration. For example, let me give you two scenarios. scenario A and scenario B. Here in scenario A, you have 5 and to 1. And then here you have 2 to 1. Okay. A or B have a higher dn over dx.
A.
Which one?
A.
A, because the difference is bigger. So when the difference is bigger, you have higher dn over dx, therefore more current. Okay. All right. Okay, similarly for hole, you have the same equation, except for this will be the hole diffusion coefficient, and this is the gradient of the hole concentration. Okay, so the hole diffusion coefficient also different for each material. Okay, sini kita dah cover access carrier ni macam we talk about generation. Let's not bother much about the excess electron or hole. It's just a term saying that if you have generation, you will have excess electron or hole. Okay. Now finish the basics. Okay, so we can have your quiz 1 soon. Now, okay, let me see. We talk about defect already. We talk about thermal already. We talk about recombination. We talk about recombination through hole already, right? Through defects. Have we talked about recombination through defects? Yeah.
You're talking about the trap assisted recombination.
Trap assisted generation recombination pun dah kan juga?
Yeah.
Okay, we talk about that. Band to band defect. Okay, tak yalah, tak penting. Okay, now yes, let's move to now baru kita masuk device. Okay, so this is PN junction is a device, and it is the simplest device for a semiconductor. If you want the simplest, paling senang to understand, are supposed to be the diode. Okay, PN junction we call also diode. Okay, so this is the simplest. So we start with the simplest, then we build from there. The simplest, then we go for BJT, then we go for MOSFET. Okay. I will tell you the significance of diode. Do you know where we use diode or PN junction?
Rectification.
What's the application?
LED.
LED, good. What else?
Current rectifier.
Rectifier, good. What else?
I've heard about clamping, but I don't understand what it does.
Clamping, okay. Clamp to will just make the voltage stay at a constant value higher than a certain level. Lagi?
Solar panel, is it?
Solar
Solar
cell.
panel.
Solar cell. Solar panel. What's the difference between solar panel and solar cell? Macam sama je.
Sama.
Ngerti ke tak?
Is it about the photovoltaic or something like that?
So what's the difference between solar cell, solar panel and photovoltaic? Pak Islamah tadi.
I'm gonna shut my mouth now.
Apa beza dia?
Solar panel.
Okay. Solar panel is a combination of few solar cell. Solar cell is the unit, the smallest unit, one unit of the diode. Solar panel is a combination of solar cell. So you use in your house is a solar panel. The solar panel consists of many solar cell. Okay. In this class, you'll be learning about solar cell. If you want to learn how to make solar panel, there will be another course, renewable energy course, which is not offered yet. We are planning to offer, insyaAllah lah, soon in the electronic. You can. Okay, so apa benda tu? Apa lagi? Apa lagi guna untuk ni PN junction? Siapa yang tidak bersuara lagi sila bersuara. You know who you are. Kita sendiri tahu lah.
Voltage multiplier.
Apa Salihin?
Voltage multiplier.
Voltage multiplier. Okay. Okay, what else?
Sensor.
Sensor. What kind of sensor? What do you mean by sensor?
Temperature sensor.
Temperature sensor. Temperature sensor. Temperature sensor. Boleh juga. Kan? Saya baru ni pakai kat dalam saya punya lab. Dipanggil diode, sensor diode. Biasanya banyak, if you buy a sensor, temperature sensor, dia macam-macam jenis. Ada thermocouple, different mechanism to measure temperature. So salah satu yes, ada jual temperature sensor guna diode. Lagi? Lagi? Najwa? Apa? Tak dengar. Out type lah.
Gelok.
Aina dah terkeluar pula. Allah, kesian Aina. Tadi nampak dia hang juga. Okay. Hambali? Logic gate? Logic gate. Logic. Okay lah. Boleh. Logic gate. Hambali?
I guess it's one transistor.
Hah?
The
Tak
logic
keluar
gate is
suara
based
pula.
on transistor, right?
Dah tak keluar suara lah Hambali. Pula sekali lagi. What's wrong with your... Sekejap, okay. Macam cik semua. Okay. Alright, so banyak. Okay, let me draw. Walaupun nampak macam simple lah. You will see after this, the mechanism is not very complicated. Okay, tapi it's actually a lot of use. Just by understanding PN junction. And for your information, my PhD, 5 years of my life, Saturday, Sunday, I'm learning about PN junction. Imagine tak ada kerja lain dalam hidup ni. Isnin sampai Ahad. 5 tahun, ada saya rasa cuti berapa bulan je dalam 5 tahun tu. Just studying PN junction. So you can ask me anything about PN junction. I'm supposed to be the expert in PN junction lah, supposed to be. Sebab dah 5 tahun, kalau tak expert juga memang teruk benar lah kan. So PN junction, normally people will like ignore PN junction lah because it's just the simplest device. People will go for MOSFET and everything, which is good. Tapi because the beauty of it, very simple, it's easier to make, therefore cheaper to make. The technology required not as high as the other devices. So apa nak cerita ni? So if you have a quadrant, so now I want to introduce to optoelectronics. Optoelectronic means devices that that uses photon or light. Opto means something electronics that uses light. What's the difference between optoelectronics and photonics? Have you heard about photonics? Sama, it's the same. Optoelectronics is electronic using light. Photonics also anything that deals with electron and photon. So photonics dia macam lebih luas, macam dia macam quantum cryptography is also photonics. But quantum cryptography, for you, they use a light to do the cryptography. But in the end, to implement it, they have to use this optoelectronic because you need electronics to implement to make the device. Okay, all right. So this PN junction, Okay, simple diode. If you bias it, forward bias, forward bias, this is voltage, this current. If forward bias the device, you will get the same LED. The same diode. You can use it as an LED, and you can use it as a laser. The same diode. You ambil keping, a piece of PN junction. You forward bias it properly. You can make it to become, if it's a direct bandgap material lah. So for optoelectronics, all material should be direct bandgap. If it's not direct bandgap, what do you call it? If it's not direct bandgap material, you won't get light coming out. Tapi tak juga. Okay, no. Kalau LED dengan laser, yes, you need to have direct bandgap because it will give out light. So saya tulis ya, it need to be direct bandgap material. So next is if we reverse bias the same PN junction, you can use it for photo detector. And this is the one that Aiman was talking about, sensor. Okay, so the same PN junction, you reverse bias it, you can use it as a photo detector. Then sometimes we say detector, sometimes you use the word sensor, it means the same. Then if you shine light on the same PN junction, it becomes a solar cell. Okay, with the same PN junction. But if you want to further increase the efficiency of the LED, laser, solar cell or photodetector, yang tu masa tu we tweak. Tu yang macam we add more advanced features to the PN junction. But generally, if you take a piece of PN junction, it can work. If it's a direct gap material, it can become LED or laser. Photodetector, it doesn't have to be direct. It can be indirect material, can also give you photodetector. Solar cell also no need to be a direct bandgap material. Okay. All right, so I just want to show you how big this is, if you understand just the PN junction. Okay, any question up to here?
So that's why we apply reverse bias for our project, madam.
Yeah, reverse bias because it works in reverse bias. After this we will learning. No, not we be learning, but you will be presenting. So the assignment for this course. So as I mentioned, we don't have midterm, we have assignment. After you finish the PN junction, I will straight away give your assignment, which is you are supposed to present on the LED, laser, solar cell, photodetector. So we'll be learning from your friends, not me. Saya akan betulkan apa yang salah je. Bateri pula tak ada ni, okay. Okay, apa benda ni? Alright, so this is okay. If you look here, kalau baca ni semua faham ke?
Tak baca lagi, madam.
Kita bagi awak baca. Tak payah saya ajar. Saya cerita yang ni. Sebab yang saya ada buat video on the energy band diagram of a PN junction. Yang tu you tengok. So now I will talk about yang sebelum energy band diagram. Okay, brothers and sisters, the way we explain PN junction, you have two ways of explaining how does it work. Okay, kita ada dua cara. One way is using the what you call it, the semiconductor structure to explain. And the other one is using energy band diagram. The one that you normally learn in your first year of electronics or in your SPM mostly are the semiconductor structure. Why? Because it's the easiest to understand. But in this course, you'll be learning both, and I I am expecting for you in the quiz or final exam to answer in terms of energy band diagram. But I will also explain the semiconductor structure. So you will start like darjah 1 dulu lah sebelum pergi darjah 2. Okay. So let's learn about the semiconductor structure. So what happens is, I think there are a lot of videos out there. Kalau saya tak ajar pun, awak pandai-pandai belaka kan, awak boleh Google je, watch the video. So saya tak payah ajar. So if you take two pieces of semiconductor, you take semiconductor, let's say dua-dua ni homo junction. Dua-dua ni homo junction, you remember what's homo junction? We talked about homo junction before, right? What does homo junction mean?
You mean homo structure?
Huh?
You mean homo structure?
Oh, okay. So I use the word homo structure. Okay. Homo structure means any structure with one material. Hetero structure means structure with many material. When I say homo junction, it means junction means you the junction dua material, two material. When the place where it meets is the junction. Okay, the place where it meets is the junction. So when I say homo junction, when you put two materials together, the two materials are from the same material. If I say hetero junction, it means that this junction are made from two different materials. For example, this one is silicon and this one is germanium. Homo junction means both silicon. Okay, so let's look for homo junction first, the easiest. Let's say this is homo junction and silicon. But the difference is we dope it differently. So this is N-type, this is P-type. Okay, so now I have a material of N-type and P-type. And now what I do is I put them close together. What will happen? Anybody can tell me? From what we learned just previously. So now we put them close together. What will happen? Diffusion. Good. Why?
The left silicon has more electron concentration, and the right silicon has more hole concentration.
Okay. So the majority carrier here is electron. What's the minority carrier here?
Hole.
So you have to remember when we talk about P-type, there's a majority, but don't forget that we still have minority carrier of electron. So this electron, this higher concentration electron, they will see a lower concentration of electron on the P side. So they can see each other. So what happens is this electron will diffuse to the P side. So similarly, the hole here, you have a lot of hole here. And here is a minority, the hole is minority, you still have it, but minority. So there's a difference in concentration gradient. There'll be a difference in concentration, concentration of the carrier. Therefore, there will be also drift, so diffusion of hole to the other side. Okay, the first thing that happens is diffusion. Next, what happens? Can you guess?
In equilibrium.
Dia tak sempat masuk equilibrium. Okay. Remember everything that I teach you. Now this free carrier of hole are going here, and they are seeing of a lot of free carriers of electron. And this free carrier of electron go here, see a lot of free carrier of hole. What will happen?
Recombination.
Yes. The second thing, when they move, they flow. Kan yang ni pergi ke sini, this one goes, and means that the second thing that will happen is recombination. Okay. So where does the recombination happens first? Does the recombination happens? Okay, kalau saya dibat macam ni kan, kalau lain. Kita masa lagi. So let's say region A, B, and C. Where does the recombination occur first?
B.
So Faiz say B. Orang lain?
B.
Okay, semua kata B. Why?
Because it's in middle. It's nearer.
The closest. The first it will cross. The first it will meet is at the junction. Sebab tu nama dia PN junction. Sebab junction tu sangat penting. Many of the most important thing that happens in a diode or PN junction is in the junction, at the junction. Okay, so tu nama dia PN junction juga. That's the where the the exciting things happen in the junction. So okay, so now we have recombination. Okay, in this area, padam pula ni. So dalam ni ada recombination will occur. Besarkan sikit. So recombination will occur. After recombination occur at this region, what is left?
Neutral. Sorry.
Apa?
Neutral particle.
What do you mean by neutral particle?
Because the positive charge of the hole combined with the negative charge of electron, it becomes neutral, if I'm not mistaken.
What is neutral? Apa yang you are going to the right direction tapi tak berapa tepat. What is neutral?
Neutral charge.
Particle.
Bound particle.
Particle tu apa?
Bound.
Bound apa?
Bound particle.
I want to say ion, but no.
Okay. Bound particle, yes, maknanya you are losing the free carriers, right?
Yes.
Betul tak?
Yes.
In this region, no free carriers, right or wrong? Right.
Yeah.
Sebab we have recombination occurs here. Now, what is left? When there is you are losing free carriers, apa yang tinggal kat sini takkan berlubang kot.
That's what I say.
What is left?
Wait, electron came from the atoms? Oh, main the most okay.
Semua tempat ni ada atom. Takkan tak ada atom. So what is left here? What kind of atom?
Hole.
Covalently bond atom. Never. No.
Benda covalent bond ni. Apa
Sorry.
Azam? Apa Azam?
Spoiler balls.
What did you say, Azam?
Hole.
Kan kita dah hilang
Dah
free
hilang.
carriers kat sini.
Hmm.
We have recombination. We are losing free carriers. We're losing both electron and hole. Here, okay. Let's do this. Okay, since you bawa macam tu, okay. So maknanya bila electron, so now we have electron diffusion over here, hole diffusion over here, right? Okay, so meaning this hole will go over here and recombine. This electron will go here and recombine. Okay, betul?
Betul.
Right? So here you are losing apa? You are losing which free carrier? This side first.
Let's say
Using electron.
You're losing
Electron.
electron, right? The electron are supposed to be here, which is attaching to the atom. You are losing it now, the free carrier. So here, which you were supposed to have hole attaching to the atom. Sebelum ni, semua atom kat sini ni, although you have free carriers, you have electron and hole free carrier, but the atom is neutral. You understand? Well, although it's n-type, p-type, but the atom ni is neutral. Total number of electron tu equals to total number of proton.
Oh,
So,
okay.
proton. So that's why there's no charge of the atom. It's neutral. Okay. So jangan tertukar between electron hole dan proton. Kita dah clearkan benda ni sebelum ni. So bila so maknanya all the atom over here are all neutral. Suddenly in this region you are losing the electron and hole. So what happens to the atom?
Becomes ion.
Okay, so good. So become ion. What kind of ion over here?
That one is positive ion.
Why?
Because you lose electron, right?
So good. So what happened here? Because you lose electron here, you become positively charged ion. And over here, over this side, it becomes
negatively charged ion
why?
because
Losing whole.
losing hole.
Because you are losing hole. Okay, so here the atom here. So because previously it was neutral. Once you lose the electron here, it becomes negative. So it becomes positive, sorry. Right? Because the number of proton here is more than the number of total number of carrier. That's why it becomes a positively charged ion. So if you understand this, you don't have to memorize. Sebab kadang-kadang dalam exam, kadang kita main blank ke apa ke, understanding helps daripada menghafal. Okay? So you understand why it's positive and why is it negative. Any question up to now before I proceed? Aina, are you there? Aina, ada ke? Nampak muka Aina ni.
Tak ada madam.
Aina tak ada dah. Hilang dah Aina. Tinggal Najwa je. Okay Najwa. Faham ke? Oh dia cuba masuk. Internet Aina ni dah 3 kali dia cuba dia masuk keluar. Najwa, ada soalan?
Setakat ni faham je.
Ya ke? Saya tanya awak soalan boleh?
InsyaAllah boleh jawab. InsyaAllah.
Okay. Tak apa.
What is life?
Kita tanya nanti. So okay now okay, so it means that we have recombination occurring. So saya akan padam ni. So number 3, when you have recombination occurring, you are left with this region where you have ionized atom, okay, or ion. So sometimes I use the word ionized atom, sometimes I would use the word ion. So you are left with ionized atom here. So this region where you have this ionized atom is called, siapa tahu nama dia apa? What's the name?
You said it before.
Depletion.
The name is depletion region. Why? Because the region is depleted of free carriers. Because this region is depleted of free carriers. There's no free carriers there. So this region, when recombination occur, it creates depletion region. Okay, it creates depletion region. Say, okay, good. Next, what happens? Tak habis lagi cerita dia ni. Okay, next what happens? Yes.
It become harder
Yes.
It become harder for the free carrier to move from high region to the low region.
Yes, it's true. It makes it harder. So, but why is it harder? So how? Okay. Have you seen a battery before?
I mean,
Have you seen a
Yeah.
battery before? Do you know how a battery works? What's inside the battery?
two
Carbon.
different minerals, right?
Aiman? Pernah tengok apa benda dalam bateri tu? Kenapa dia tiba-tiba boleh keluarkan current? Pernah terfikir tak?
Lithium.
Kadang-kadang kita orang pakai je, tak pernah tahu. Oh, macam tu engineer. Okay, so sabar. So, sebab saya kena macam tu dengan supervisor saya. Dulu macam tak tahu dia akan kenakan saya betul-betul lah. Lepas tu saya akan Google bersungguh-sungguh to make sure that saya tak nampak bodoh depan supervisor saya. Macam itulah. Hidup kita macam gitu. Orang tembak kita, we should stand back again and prove they are wrong. And jangan nampak bodoh 2 kali. Sekali tak apa sebab kita belajar. Kalau berkali-kali bodoh ni something wrong. Okay. So you can Google after this how a battery works. Okay, because you can understand. If you understand this semiconductor physics yang sangat payah ni, ramai orang tak faham. You can go ask any lecturer kat situ. I can bet you ramai yang tak faham ni because it's very niche. Macam out tanya saya lah, how a wireless thing, I also don't know. If you can understand this, you can understand how a battery works. Basically, battery, they have material that have ions in it. Macam ni, sebiji macam ni. So they have positive charge ion on one side and negatively charged ion on one side, which means that now, by having this depletion region, we are creating an internal battery. Okay, sebab kita ada ionized atom ni kan. Basically, it becomes a battery. So kalau battery, it means it gives out voltage, right? Right. So basically, so then you will get okay. So you get apa nama ni, a battery. So the direction. So this becomes a battery, and you have electric field.
Positive to negative.
So what's the direction of the battery? So direction of electric field.
Positive to negative.
Yes. So the electric field will be this direction. Okay.
I see where it's still going. Okay, got it.
So the electric field will be in this direction. Guess what happens next? Saya takkan tanya benda kalau saya tak give you the foundation to think.
What the question, madam?
So now we have this built-in electric field.
Drift.
What happens next?
Drifting.
Drift. Good. So what drift from where to where?
From where to where?
Kan drift lah. Orang kata drift kan. Apa yang drift?
The positive ion.
Wow.
No.
The ion now drift. Atom tu
Oh, the electron. The electron. I mean the electron.
Electron
The electron drift.
will drift from where to where?
From negative to positive.
So tell me
Against
here.
Opposing to
Against.
the electric field.
Against electric field.
Yes.
So daripada mana dia pergi? Daripada sini ke sini?
Kanan ke kiri.
Kanan kiri.
Alright, good. So because of this electric field, the built-in electric field, we call it, dulu kau panggil dia built-in voltage kan? Now you know why we have built-in voltage. Dulu hafal je we have built-in voltage VBI. But now you understand where the VBI coming from. Because of this depletion region, you have this built-in voltage. So this built-in voltage, remember electric field, when you have built voltage across a distance here, you have electric field. And when you have electric field, you have drift. So the drift is the electron will drift in towards the positive side. So apa ni? So electron will drift over here. Saya ambil color line juga. Coba color apa? Color purple. Kalau awak color blind, tak apalah. Those are not color blind, it's easier for you. I try to change the color. So electron will drift like this. So the red color here is diffusion, remember? And this purple color is drift. So electron will drift over there. How about the hole? The hole will drift to this side, right?
Yes.
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 Okay. So the hole will drift there. So can you see now? So okay, before that kita tulis dulu. So what happens after depletion region? We have built-in
Voltage.
voltage and electric field. Then number 5, we have after that drift of carriers. Number 6. So now you have drift. So next, what happens after you have the drift?
More of the thing. More
Can
of
you?
the something that happened before. I'm
Mm,
giving them some hints.
I can't hear you.
I'm giving them some hints. I'm saying that more of the things that happened before.
No, you don't give me
okay.
hints. You just give me answer.
Oh, you want me to give?
Yeah.
Okay, so because of the drift, the depletion region becomes bigger because more electron commits. No, serious.
No. Seriously, you say me say I will answer. Yes, seriously. I don't joke in my class.
Sorry,
Okay.
but
Right. So now, okay, the clue is can you see the direction of current? So you have 2 types of current now, right? Number 1 is the diffusion, number 2 is drift. Can you see the direction of the current? Can you give me what happens next?
what's the net current?
So the net current will be
0,
why?
because one move dia macam mana? Opposite the total number of total something total hole and electron drift. Is it?
So in equilibrium, so it will try to reach equilibrium. In this equilibrium, what happens is the what do you call it, the drift, the diffuse current will be equal and opposite direction of the drift. So dia tak boleh pergi dah. If you know the diffusion here, when if you want to go over there, they need to overcome the depletion region. So there will be a certain limit, and the drift cannot go further. You will not keep on increasing the drift current because you have this opposing of the diffusion. So in the end, dia akan ada middle way path. Dia akan compromise. So in the end, in equilibrium, it will stay like this. So at zero bias, this is what happens at zero bias. Which means that I didn't apply anything, right? I didn't apply an external voltage to it. What I did here is just putting 2 material together. Just putting 2 material together, I got all this happening inside it. So at zero bias, basically this will happen. And if you take a piece of PN junction or diode, you take a piece of diode macam ni, and you touch it, there's no current. Why? Although inside it is actually other diffusion and drift. It's already you have inside here, but it's cancelling each other out. So when you to the outside world, there's no current, net current, because it's equal and opposite direction. Okay, you understand? Any question? So we finish. So this is the explanation about semiconductor structure for for zero bias. And you can go and find for the forward and reverse bias, you can find the internet. Lambat ajar. So macam you can go and find out. If you don't understand, ask me next class. So basically kalau forward bias, you just connect this to forward means you connect the P to the positive and to the negative. That's forward bias. Reverse bias, the opposite. You connect the P to the negative and the N to the positive. And I want you to think, go and watch videos, and I want you to think where are the carriers will move inside here, because now you understand up to here. You know there are carriers. So sekarang ni dia start zero bias. After this, when you apply this when we apply this bias, what happens to the electron hole inside the structure? Okay, then what happens to the depletion region? The key is in the depletion region. So as I mentioned, this is easy. Sepatutnya senang lah nak faham, and you can go. I've told you the basics of the understanding of this. So if you go and read and watch a video on the forward and reverse bias, I think you can understand. So come with question if you don't understand. Next, we look at the energy band diagram. Okay. Ada soalan apa-apa before we end? Faham ah? Faham? Saya dalam kelas saya bisa tanya faham, tapi bila exam ni tulis benda lain pula. Saya pun tak tahu. Faham, if you understand, you don't have to memorize. It makes sense. Betul tak saya cerita tadi, apa yang saya cerita tu make sense tak? Right? The flow, kadang-kadang student dia memorize, dia skip. Dia skip tu sebab dia tak faham, dia memorize. Sebab tu dia memang ada flow dia satu ni, then recombination, then depletion. You cannot have depletion region without recombination. Cannot. You cannot have drift without the depletion region. You cannot have drift without the depletion region or without the built-in voltage. So flow tu dia cantik. So bila awak skip dalam exam ke apa, memang saya tahu for sure lah awak menghafal. Then you'll be in deep trouble. Sebab awak kata
Madam,
awak dalam kelas. Yes.
nak confirmkan something.
Hmm?
Dekat recombination tu kan, kan dia jadi ion, positif ion dekat N ni. Kan? Dia sebab dia losing electron, isn't it?
Yes. Sebab
Okay.
dia losing tu sebelah junction, sebelah N+. So memang kat situ
Okay.
memang ada elektron. Yang sebelah sana tu
Dah
junction ada P, ada hole.
Dah faham.
Dah faham ah? Okay, good. Any more
Wait,
question?
if it loses electron, why can it get the free electron from N region?
What do you mean?
If the positive ion, it loses the electron, right? Why
Yeah.
cannot it get the electron from the N type region?
How will it get the free carrier? How?
Can I just
Because this
Generation.
recombination will keep on occurring. There will be electron coming and then recombine. The process dia bukan sekali. The way I explain it macam sekali macam benda tu keep on recurring. Sebabnya diffusion happen, drift ada, di cancel macam tu. So even if any carriers come to the junction, terus recombine. You understand? Whole line akan datang. So you will not get any free carrier there.
Right, it's continuous process.
Yes.
Yeah.
Okay, any more question?
Apa password untuk hari ni apa, madam?
Oh, soalan awak. Saya pun lupa. Password hari ini ialah tahajud. So sila solat tahajud semua orang. Doakan semua orang dalam kelas ni dan saya juga terutamanya.
Tahajud double J, madam kan?
Double J, tahajud. Okay, I think that's all. Kalau tak ada soalan, you can ask me next class. It depends kalau next class, kalau saya rasa mungkin we have a short class, betul saya akan bagi video ataupun kalau saya rajin saya ajar semua. Kalau tak pun saya bagi video je lah. Sebab video tu bagus juga saya rasa yang saya buat lah, puji diri sendiri. Okay. Alright, so if you don't understand, you can ask of that. I think it's quite clear. Okay, let's end the class with doa. Siapa nak tolong baca doa? Giliran siapa pula ni? Aina, kita duduk sini sampai malam esok. Tak ada orang nak baca doa.
Kembali tengah test mic, madam.
Oh, tengah test mic. Okay, test mic. Macam tak jalan je tu. Maka tak boleh orang yang kena ada mic working macam nak baca doa kalau orang lain tak dengar ni. Jadi imam tapi suara tak dengar, tak boleh. Aina, kenapa masuk keluar internet awak tak okey eh?
Sekarang pun saya tak pakai laptop lah, guna iPad sebab tak boleh langsung kat laptop.
Okey, tak apalah, nanti awak tengoklah video. Siapa 2 kali dah kan? Round kedua patutnya ke round ke berapa dah ni? Baru round kedua saja. Siapa yang baca doa?
Sikit.
Semua dah habis round kedua. Macam tak je.
Ya, saya belum baca Azam dengan Aiman Aiman yang last class, Azam yang first kali.
Saya dah baca round kedua.
Apa Saleh?
Saya tadi tak, saya dah baca round kedua.
Awak pun dah round kedua. Faiz awak dah round ke berapa?
Saya baru first round tu.
Jadi-
What?
Tak ada orang lain lah kecuali awak dah Hambali pun tak boleh bawa.
Sebab macam baru 2 orang ke 3 orang bocor.
Halo.
Memanglah 2 orang lagi sister. Tak ramai brother.
Halo.
Cepat. Kita nak
Okay.
balik ni. Banyak kerja nak masak lagi.
Sudah masak apa, madam?
Saya pun tak tahu. Saya sebenarnya duduk seorang-seorang. Saya tipu je nak masak. Mungkin saya makan salad kot. Sekarang ni kena diet. Sakit lutut dah. Okay, Faiz.
Okay. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Allahumma kshif 'anna minal bala'i wal wuba'i wal fahsya'i wal munkar wa ta'ni wal fitani ma la yakshibuhu ghairu. Allahumma kama hassanta khalqi fa'asin khuluqi wa rizqi ya muqallibal qulub sabbin qulubana ala dinika wa ala ta'atik. Wassallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa barik wa sallim. Subhana rabbika rabbil izzati amma yasifun wa salamun ala mursalin walhamdulillahi rabbil alamin.
Alhamdulillahirrahmanirrahim. Thank you very much for the doa. Hambali, please make sure your mic is okay next time.
Okay, just to make sure, who doesn't read the doa yet?
Semua dah. Hambali second tak ni lagi. So next will be third round pula. Okay, let's end the class with tasbih kifarah and surah al-Nas. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta nastaghfiruka wa natubu ilaik. Bismillahirrahmanirrahim wal 'asr. Innal insana lafi khusr illa alladhina amanu wa 'amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Bye, madam. Take care.